geometry
with
Mr. Haile.
Hey students, we're going to talk about the proofs using triangle congruence theorems, or at least a starting point. If you want a chapter reference, these are in 7-3 in our book. Let's go over some of the proofs that the triangle congruence theorems that we know so far, and this is mostly the sum total of them. We have the SSS triangle congruence theorem. We have the SAS triangle congruence theorem. Remember, side, side, side. Three sides. Two triangles with three congruent sides will give us two congruent triangles. Side, angle, side. Side, angle, side. Two triangles with a side that's congruent, an angle that's congruent, and another side that's congruent. That'll give us two congruent triangles. So remember, there are 6 components of every triangle. We've got 3 angles and 3 sides. What these triangle congruence theorems allow us to do is to not need as much information in order to determine that triangles are congruent. We've got the angle side angle triangle congruence theorem. Angle side angle triangle congruence theorem. We have the angle side triangle congruence. Oh shoot, I didn't write that right. Theorem, you know what I mean. Angle side. Just shortcutted myself. So we're going to jump right in. These are the proofs that we have to do. This is our first one. This is the information we've been given. I have a picture over here that I'm going to draw on as I go, and the drawings can really help you to visualize what's happening. We did that worksheet today. I'm in class, and hopefully that was helpful for you. The drawings can help us visualize what's actually happening. So we have angle EBA is congruent to angle DBC. So let's mark that. I'm going to mark it. This is angle EBA. This is congruent to angle DBC. So we're going to draw that. That is, this tells us that those are congruent. That little arc here. We have B is the midpoint of line AC. B is the midpoint of line AC. From the definition of midpoint, this is a little bit of foreshadowing. I know that BA or AB, the length AB is going to be equal to the length of BC. So I'm going to mark little hash marks there. And I'm told that angle A is congruent to angle C. So I'm going to put 2 arcs here to tell me that angle A is congruent to angle C. It might already be apparent to you that we do indeed have 2 congruent triangles, but let's go ahead and draw it all out. So we're going to do this with a 2-column proof. We have conclusions on our left and justifications on our right. What comes first in our conclusions? Well, of course, this is our given statements. So we're just going to rewrite those. Angle EBA is congruent to angle DBC. We have B is the midpoint of AC, line segment AC, and I could say angle A is congruent to angle C. For all of these justifications, we can just say given, because they were given to us. This is really only a 2-step proof. If we know those things, we've actually foreshadowed this already, but we want to prove next that this line segment AB is congruent to this line segment BC. How do we know that? Well, I've told you earlier, and you should be able to look at it. We know the definition of midpoint says that a midpoint cuts a segment into 2 congruent parts. So we just reference in our definition, reference in our justifications the definition of a midpoint. And our second argument, our second point in our argument. Now we've got an angle, a side and an angle, and an angle and a side and an angle, all of which these two angles are equal, these two sides are equal, or congruent, these two angles are congruent, these two sides are congruent, and these two angles are congruent. So we know we're going to use the ASA, angle side angle, triangle congruence theorem. Perfect. And what are we trying to prove? Well, we're going to try and prove this, exactly the statement. Triangle ABE is congruent to triangle CBD. So simple. Okay, great. We all ready for our next one? Well, you can pause it if you're not, but we're going to move on. Okay, we have our next one that says our given. Let's just take a look at our shape here. Looks like we've kind of got a bow tie looking shape. And let's draw on it as we know some things. We have M as a midpoint of line CD and EF. So just from a minute ago, we can know that the segment CM is going to be congruent and of equal length to segment MD. And we know EM is going to be of equal length and it's going to be congruent to length MF. Okay, so we've got that drawn. And we want to prove that triangle CME is congruent to triangle DMF. So let's make our two columns again. Our left column is going to be, say it in your head with me, conclusions. And our right column is going to be justifications. Okay, what do we always start with? Our given statements. M is the midpoint of line segment CD. That's a D. D is in dog. And our next one is M is the midpoint of line segment EF. These are given to us. We use the same rationale as before. We're going to say by the definition of a midpoint, by the definition of a midpoint, that line segment MC is congruent, that's this segment here, is congruent to line segment MD. And we can say EM, line segment EM is congruent to line segment MF. And when we say line segment, we have to put bars on top of our letters there. So just make it very, very clear. And our second thing, well, I've got side, 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 side. So in order to finish this proof, I need at least another thing. If I could figure out this other side, I would. I don't think I'm going to be able to. I'll pause it right now. So we've learned that line segment CM is congruent to line segment MD, and line segment EM is congruent to line segment MF. So we've got a side here that's congruent to this side. So I've got side, I have a blank spot, side. So here I would like to use the side angle side triangle congruence theorem, but I can't yet because I don't have an angle. So let's see if there's a way that I can prove that this angle is congruent to this angle. Angle CME is congruent to angle MFD. Is there a way for me to prove that those things are true? How do I justify that statement? Well, I referenced the vertical angle theorem. Vertical angle theorem says that if I have two angles that are back to back and the opposite sides of each angle form two straight lines, then the angles inscribed are congruent. Okay, so we've got a vertical angle theorem. That means we can say that these triangles are congruent. How do we say that they're congruent? This is with the side angle side triangle congruence theorem. So I can say SAS TCT for short. And let's give our statement. Triangle CME is congruent to triangle DMF. And we're done. Okay, one more proof. Here I have what looks like a parallelogram, but I don't really know yet. I'm gonna again use the given statements to draw on my figure to help me visualize what's happening. The things that are given to me, I'm given that AB is the same length as CD, and that BC is the same length as line segment AD. Remember, if I don't have a bar above my two letters, that's referring to length. And I want to prove that angle B is equal or is congruent to angle D. This is what I want to prove. Okay, so you can already see which triangle congruence theorem we're going to use just by the picture, probably right away. But let's get started with our conclusions and our justifications. Let's give ourselves a little bit more room this time. Justifications and conclusions. What do we start with? Always our given statements. So let's write those. AB is equal to CD, distance AB is equal to distance CD, and distance BC is equal to distance AD. Those are both given. Okay, our first argument. Okay, well, I've actually got a lot happening here. It's going to be very difficult for me to prove that these angles here are equivalent, are congruent. So I'm going to try another route. Can I prove that this line, segment AC, is congruent to this line, segment CA? Well, yes, I can. I can say line segment AC is congruent, and we can even rename it. Instead of line segment CA, we could call it AC again. And this uses our reflexive property of congruence. Which just says that things are congruent to themselves. Okay, I'm going to slide up so y'all can see. Okay, number 2, our second argument. So now I have, let's give that 3, BC, AD should have 2 hash marks. And now we have a variety of sides that are congruent to the corresponding side. So number 2, I'm going to go ahead and say that triangle ABC is congruent to triangle CDA. And this uses what kind of triangle congruence proof? I've got side, 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 and side, side, side. This is the SSS triangle congruence theorem. We're still not done. Our goal is to figure out that angle B is congruent to angle D. And I can do this through, well, if I got two congruent triangles, triangles are figures, so I can say that I've got corresponding parts of congruent figures, CPCF, which says that any corresponding parts in congruent figures are congruent themselves. And we're done. We figured it out.